Hi, I'm your host Praveen Ravisankar, and this is the Data Standard Audio Experience. We have a very exciting guest today. On our podcast, we have Mehmet Apsalan, an astrophysicist and currently a senior data analyst at Blue Ocean. Today, we are speaking about his transition from academia to the data science industry. Welcome to the show.
Hey, thanks for having me. It's my first time doing a podcast. I'm pretty excited.
Sweet. And thank you so much for coming on to the show today. Can you go ahead and introduce yourself?
Yeah, so as you said, my name is Mehmet Apsalan. I got my PhD in astrophysics back in 2014 from the University of St. Andrews, although I did part of it at the University of Western Australia in Perth, Australia. And I basically just got really nerdy about galaxies. That was the main sort of thrust of my research. And I was conducting what are called, or rather participating in what are called galaxy surveys, where we take essentially what are large telescopes and map out big chunks of the sky and identify as many galaxies as possible. And then different people go off and do different science with that. And a lot of what I worked on was largely related to sort of the geographic distribution of galaxies in the universe and how that can influence a galaxy's formation and evolution, or sort of put it another way, do galaxies care about their neighbors, and how does the clustering of galaxies tell us about physics of galaxy formation, galaxy evolution, as well as sort of more interesting questions about the underlying distribution of dark matter in the universe. But to put it differently, it was kind of like doing data science in space. I just had big data catalogs that had galaxies in them rather than house prices or things of that nature. So I would say that I did a lot of what we sort of informally called astrostatistics, of doing interesting statistical analysis on astrophysical data sets. I then subsequently did a postdoctoral research appointment at NASA's Ames Research Center in California, which most people I think are more familiar with the fact that it's right next to Google's headquarters, the Googleplex. And from there, I went to New York University, where I did another postdoctoral research appointment. And then last year, I transitioned out of academia into Blue Ocean, where I've been working as a machine learning engineer and data scientist, and doing all kinds of very, very interesting analyses on different kinds of media, textual, image-based data, and all kinds of sort of interesting analysis on this kind of stuff, and a more sort of marketing avenue.
Sweet. It sounds really impressive, and it's like super exciting to me, especially since I'm like an undergraduate researcher, and I'd love to hear more specifically about like not only the topics about what you researched at NASA, but also the real applications of how data science actually helped, more than just being able to run regressions. Like I was wondering if you guys use like computer vision, anything like that that really bolstered your research there.
So I think that's actually a very good question. And I'd say that the most significant way in which astrophysics research impacts sort of broader data science principles, or perhaps I should say, provides someone with a unique insight into data science that perhaps is harder to gain in other ways, is this idea of very, very careful experimental design and sample selection. So to give you some context, in astrophysics, we can't really repeat experiments. Especially in the field that I'm looking at, you may observe a galaxy and you may make some prediction about what that galaxy is going to do, but it'll take 1 billion years for that to happen. So you can't really go to a lab and say, okay, well, let's try this out, let's try this out, let's try this out. You instead have to be very careful and essentially observe as much of the universe as possible in order to gain as much insight as possible into the various different stages of a galaxy's life cycle. So while you may not be able to watch a galaxy evolve from infancy to its final millions of years, you may see snapshots of galaxies that are forming, galaxies that have just formed, those undergoing evolution, and so on and so forth. So what that means then is that if you're doing any kind of statistical work related to understanding what is driving some of the properties of these galaxies, you have to be very careful to do things like taking into account collinearities. For example, in my work, I wrote a paper where we thought we had discovered some very, very interesting effects related to the properties of galaxies and their geometric environment. But it turned out to be that we were simply recovering, or rather rediscovering, a previously known interaction between a galaxy's mass and all of its other properties. And this was because I hadn't taken into consideration that the sample that I was looking at was heavily biased in this sort of stellar mass space. And so that's a lot of jargon, but what it really means is that you become very, very good at anticipating the caveats of the work that you're going to do. And just as you said, you become very good at coding and you pick up a lot of skills in different types of regression, sometimes machine learning, depending on what you're doing. But the real intuition, I think, comes from being able to design these experiments carefully, perform your statistical analysis carefully, and then be very conscientious about the statistical and mathematical limitations of the work that you're doing so that the conclusions you arrive when you are publishing your research are as reliable as possible. And just to wrap up, I think the way in this which this translates well into sort of non-academic data science is that you gain a very, very good feeling for doing good, solid, reliable statistical work. So, now through my work currently, if I sit down in front of a client and a client's asking me about the validity of the work that I've done, I have the background to be able to tell the client, based on this analysis that I've performed, I can tell you, these facts. And there's very little speculation in that sense. And I think that can be particularly useful, especially now as we transition towards an era where, we are really democratizing the access to machine learning, which I think is fantastic. But due to the nature of some of these algorithms, it's very easy to pick up and use them without fully understanding the mathematics of what's going on behind them, as well as taking into consideration more subtle statistical things like, the fundamental underlying assumptions behind linear regression, for example, and talking about Gaussianity of your data and heteroscedasticity and all these other things. I think it helps to have this sort of firmer, more solid mathematical and scientific foundation in data science work. That being said, I think it's also useful because astrophysics is it's an interesting field because you end up doing a lot of different kinds of statistical analysis and data science work. So in my work, I've done everything from image analysis using CCD images to working with catalogs and, data cleaning and data munging. I've never figured out how to pronounce that word, but, combining data sets from different places together. So I think it prepares you in a very good way to have a basic skill set for data science. And it's evidenced by the fact that a lot of astronomers that leave academia do end up in data science in some way or another.
Wow. So I guess it's not as plug and play as other people say, right? I feel like within academia, domain knowledge is probably the most important thing before any application of these data science tools. That makes a lot of sense. Yeah.
Yeah. And it's often the case that you can have a very good idea that is perhaps hampered by a desire to apply a particular statistical technique that is in vogue, but not necessarily the appropriate one for the case. And so machine learning has been something that's still, quite new to the field. And while there have been some really, really interesting works that have used machine learning techniques, in particular, recent work looking into using GANs to detect bad observational images from telescopes, that's been fantastic. But there are also applications where training sets are used in ways that are perhaps creative to derive generalized conclusions about the universe that I think are an interesting application of the tech, but are not necessarily giving us the kind of scientific insight that we are looking for.
Oh, that's super interesting. It's kind of daunting to even realize any of the predictions or any of the work that you do can't really be proved for billions of years, I guess. And
yeah, it can be challenging.
Yeah. But I know you kind of touched on this earlier in your response to my other question, but as someone who's kind of made the transition and you've worked in industry for a while now, what's the main difference that you saw between academia, research, and working in the industry? Is you could talk about maybe how it works with teams or working with the data itself and how that's different. I mean, it's up to you.
Sure. I think the biggest difference that I've noticed is that there has to be a strong business justification for a lot of the analysis and research that you're doing. In academia, you can get away with a lot of so-called blue skies research where you're, talking about exploring something for the sake of exploring. And I think that there's it's creatively very rewarding sometimes. But the caveat, of course, is that your research may not necessarily lead to an interesting solution, but you still have that sense of freedom to go out and explore and discover. Now, in the industry, that can be a little different. You often have to have a good business justification for work that you do prior to even doing it, simply because your time is worth a lot more money in industry. And so I've been faced with a number of cases, over the year where I've been working in industry where even myself, I have looked into, thought about doing a certain kind of analysis on some of the data that we have as a company and thought, well, this would be fascinating to me on a personal level. It would be an interesting result. But this may not necessarily be something that we can monetize, or it may not necessarily be something that could bring us a lot of extra revenue. And so you have to weigh up the cost of how long it might take you to do some kind of analysis against the potential return of what that analysis can be. So that was probably the biggest thing that I noticed, but that took a while sort of to sink in. The first thing I noticed when I started is just everything is a lot faster. Which to me is great. I like fast-paced sort of work. I enjoy having multiple projects at the same time. And certainly personally, having worked at a startup, you get very used to doing all different kinds of work and wearing lots of different kinds of hats. There is, of course, the flip side to that, which is also really beneficial in the sense that as an academic, you often also put on lots of different hats, but often in a more administrative way. So you may have to worry about balancing your budget for a research proposal or mentoring students, or even spending some time to think about the visual presentation of your work. And often at a startup, what's really nice is that you have colleagues who are experts in that exact thing. So I think it was my third or fourth day and I'd produced a visualization for my boss. And I mean, this sounds like such a simple thing, but it was really eye-opening to me. We have our staff sort of designer had already come to me with a list of color palettes to use for this visualization, which again, it's very small, but I spent so long thinking about how I should, present my work, what colors may look best for the graphics that I'm using in my papers, taking care to make sure that they are colorblind safe and all of these other considerations. And now there is somebody who is expertly trained in this that is giving me advice and insight. So the teamwork aspect is incredibly rewarding because rather than having other scientists to work with, which is always great, you have people whose subject domain in different things almost sometimes means that you can do more science because you have more time to really crack into your topics of expertise, which in my case were, this kind of statistical analysis. So yeah, I would say that it's this sort of combination of faster paced research, working with people whose skill sets are very different to what you've encountered before in academia, and then having to come up with a lot of sort of business justifications for the work and research that you're doing.
Yeah, that makes sense. And kind of to build off of that, like when you did make the transition from academia to the industry work, like were there different tools, different skill sets that you needed to learn in order to function better, like as a startup? Because I feel like they're pretty different jobs, right?
For me, it was more a case of picking up some more widely used tools in data science to be able to add those to my resume, but as well as that, get through things like technical interviews. So the majority of astronomers use Python, as do the majority of data scientists these days. But there's a couple dozen of us that use R, and we are very, very big fans. I will happily die on that hill that it is my favorite language. I love it. It's a statistician's dream. But of course, when you are applying for positions that require experience in things like Python and scikit-learn and all of these other machine learning tools, you do have to show some previous experience with using these tools, or at least some of these techniques. And so I was able to do that primarily by engaging in self-directed research project as an academic. So I, had some forays into machine learning and applying machine learning techniques to some of the galaxy research that I was doing. And I also just, hit the textbooks. And I think that as an academic, there's one thing we're good at is hitting the textbooks. And so I picked up textbooks on Python and statistical analysis and all these other things, and essentially brushed up on a lot of those topics in a way that I think allowed me to talk about them in a more formal sense. And this is very niche, and I think perhaps it may appeal to your listeners who are also academics, but often in academia, we end up teaching ourselves a particular tool or technique to get a job done, but we don't necessarily always have the time to really learn the fundamental theory or mathematics behind some of those tools. And so going back and reading over the fundamentals of probability and linear regression and all these other things, I felt was very useful in being able to address some of the questions that I faced during technical phases of interviews, especially those where I was requested to discuss the theory behind certain tools rather than doing live coding exercises. But I would also say that practicing coding problems was a big part of the preparation. Again, A lot of the coding questions are ones that you don't necessarily encounter very often in research, primarily because as an astrophysicist, the efficiency of your code, for example, isn't necessarily the biggest thing that's on your mind. You know, for some of us in the field, it is, especially the folks that run these beautiful simulations of universes or do very, very sophisticated statistical analysis that has a time component to it. But the work that I did, you know, efficiency wasn't really the name of the game. As long as the results were accurate, it didn't really matter if I had to run the computer overnight. And so brushing up on some of the more general computer science skills I felt was very useful. But really, all in all, it felt like studying for exams all over again. So it's familiar
Yeah.
territory. But I also think another important skill was being able to really take the research work that I had done and find some way of extracting the most important aspects of it that were most relevant to the different jobs that I was applying to. And I often see this now in colleagues of mine that are thinking about transitioning out of academia. You know, they have these wonderfully impressive resumes that are full of their accomplishments, but a lot of them are written to an audience that is essentially more astronomers or more academics. And so it can be very difficult to distill all of that information down and really pull out sort of the salient points that may be of more interest to a more general audience that highlights both your skills as a scientist, as an analyst, while at the same time indicating that, you know, if you do join a company, if you do join a team, you will have the capacity to explain your work to your colleagues in a way that is understandable to all of them, while at the same time avoiding perhaps this unfair trope of a scientist that kind of just goes off on their own and, you know, puts their head down and works for days on end and comes back with this sort of inscrutable product. So, you know, you definitely learn to communicate better.
No, that makes sense. And kind of building off of that, what do you feel like is the most undervalued part of working in a startup versus working in academia? And not more so it doesn't have to be just about like the data pipeline or anything like that, but more along the lines of how are these tools more useful to you? How is the data different? And things like that.
So I would say that it's harder. So in particularly my experience in academia, the biggest difference is that a lot of the data that I worked with as an academic had already been cleaned and structured to some extent by its owners.
Mhm.
And so I was often not really faced with a job of cleaning data, but rather merging different data sets was more of an exercise in careful sort of bookkeeping and scientific work. So for example, merging two different data sets of celestial objects, you know, same patch of sky observed by two different telescopes that carry different kinds of information, but they're looking at the same targets. And so you have to do things like making sure that the targets that you are matching are actually those, you know, you may have one galaxy in the sky and another galaxy in the sky, and you want matching observations of those two. And you want to make sure that you are sort of overlapping the same two observations and not two galaxies side by side. So I'd say it's more an extension of careful scientific work rather than, you know, data scraping and data acquisition and things like that. At a startup, that can be a lot different, particularly depending on the industry that you're working with. But I feel like one big difference is that you get a lot more into the weeds when it comes to things like data acquisition, data cleaning, as well as, you know, thinking about the long-term uses of your data. So this is something that I used to, you know, I spoke about quite often, but in astronomy, we produce a tremendous amount of scientific output from archival data sets. You know, so these are data sets that have come from telescopes like Hubble or some other telescopes and have been archived very carefully by experts in a way that is very easily accessible and well documented. So what that means is that the barrier to entry for doing science with this data is considerably lower than if it were unstructured and unmaintained, which then allows for just a huge amount of scientific output. And when you're working at a startup, you have to think about things like this too, particularly if you're at a young startup like I was, where really there's a rush to acquire data, there's a rush to produce deliverables for your clients. But at the same time, you need to be able to think about the long-term uses of the data that you're obtaining, as well as the data that you're generating, so that you can do things like meta-analyses down the line. And so you get I think a big difference in industry is that you get a much bigger insight, as well as the opportunity to be contributing to data infrastructure, you know, data engineering and things of that nature that can both be interesting and challenging. Personally, I have very, very little experience with things like data engineering or thinking about how to set up a data warehouse and things like that. So you forced to learn, but if you're intellectually curious, I think that can be a lot of fun. And what's really rewarding is that you really get to sort of build your own niche within the organization, especially if it's a young one, like a startup. If you can identify a problem and propose a useful solution to it, that can really be that thing that you own. And often that means you have a little bit more freedom in the kinds of work that you're doing, especially because often you end up defining the process as you go.
That makes a lot of sense. And more along those lines, when you did make the transition from academia to industry, why did you specifically choose like SaaS and marketing rather than something different? I mean, like more sciencey, I guess.
I wanted to really, I've always been very curious about the ways in which numbers and data can reflect human behavior, which I think is kind of an abstract thing to talk about, but it's been very rewarding over the past year to work at an organization where I can look at current events that are happening in the world, particularly revolving around brands and products, and see public perception reflected in things like the sentiment analysis performed on content where people talk about those brands, or the way in which a company's certain creative outputs or creative products can change to reflect certain trends in the world. So without going into too much detail, it's been very, very interesting to look into vocabulary used by some of our clients and some companies in different parts of the world, and then connect that back to how those different regions faced the COVID pandemic. And so it's been very interesting to me, sort of on a very personally, intellectually curious level, to be able to quantify this sort of human perception and behavior in the marketing space through data. And that to me is a personal curiosity, and that's been very, very fascinating to be able to do. But I also wanted to join a startup at an infancy level to be able to really see how that works, but also have, a measurable impact in the growth in organization. And most importantly for me, it was being able to sort of see the output of my work being put into use, being able to say, I built this, I did this, and now it's part of the company. That's been very rewarding.
That's really cool. And I know it's kind of random, but is there anything interesting that you found, especially during like the COVID-19 pandemic, from your analysis?
I don't know how much of it I am allowed to talk about due to NDAs and our clients, but
yeah, of course.
I will say that it's been very interesting to see how marketing organizations and marketing wings of companies are able to analyze current events in countries and change their language and products to reflect that. And I think that has, to me personally, revealed a level of detail that I didn't really know was in marketing. As somebody who has always approached marketing from the perspective of a consumer or, the target of marketing, it's been a very interesting ride to discover some of the thought processes that go into preparing content for me to consume as a consumer. I have a lot more admiration for the work that those folks do now, because I think sometimes as scientists, we can be a little, at least that seems easy. Why is that so challenging? And I think that's a very hubristic thing to do. It's kind of arrogant. So now I really have to say I've developed a much bigger respect for the kinds of creative work that goes into marketing.
I'm glad, I guess, the industry humbled you or something.
Yeah, but, no, I think it's useful to come out of I think more broadly though, it's very good to come out of your sort of shell and expose yourself to different thought processes of different people. And I think that it's an even bigger benefit to working within teams in academia where you're surrounded by other scientists to work with teams of, strategists and marketers and engineers and designers and artists. And really, I think it's a much more holistic approach to work. And I find that it's much more rewarding.
Oh, yeah, that makes sense. So we at the Data Standard are building a community for data enthusiasts like you and data thought leaders, and everyone is open for collaboration and to connect with each other. I was just wondering, do you have any ideas of what our community could do for you, or are there any interesting things that you want to share with the community?
I think that's a very good question. I think one thing that I probably benefited from greatly is, so my wife studies statistics as well, and she has been and always will be a much, much better student than I ever was. And so when I started preparing for some of these interviews and starting to brush up on my skills, the only reason I had all of these incredible textbooks on hand was because she had already read through them and had already gone through them and knew which ones to recommend me. And I think that was an invaluable resource. And I absolutely credited it for getting to where I am today. And so I think having that kind of peer support would be tremendously useful, particularly when it comes to the recommendation of content for practicing on. I think, people have these recommendations for different websites and different books, but I think that having, field specific recommendations could be useful, so that, there could be mathematics or statistics textbooks that mathematicians and statisticians may wish to recommend to each other, or perhaps certain packages used in certain fields for Python may lend themselves quite well to, wider uses of data science. I'm spitballing, but I think generally speaking, just having a place where people that have gone through the ringer can go back and really share some of that information can be very useful. And that's something that I've tried to do personally in my life too. Even things like looking over people's resumes. I think it's a really big difference to see what kind of a resume you want to be putting out there if you're trying to leave academia compared to when you're trying to stay. And, having that sort of peer support network, I think more generally is something tremendously useful.
No, yeah, I totally understand. I feel like a lot of the information, at least for learning data science, can be super overwhelming. Like you don't really know where to start, or like, especially from like where you are. Something like that.
Yeah.
Well,
and I also think that a lot of documentation can sometimes be written with computer scientists in mind rather than statisticians. This is something that I've run into a lot. So, having people with more of a scientific background who are sort of there to talk through these kinds of things, I think would be helpful.
Sweet. And well, thank you so much for coming onto our show today. We really appreciate your time, and I really enjoyed our conversation. Where can our community find you online?
So I infrequently post on Twitter, but not really about data science. But my handle is @Memzi. Be forewarned before going in. Other than that, I don't really have much of an online presence. My GitHub is unfortunately quite bare because most of my pushes over the past year have been going to a private server. But yeah, if anybody wants to reach out, I'd be more than happy to talk about the process of leading academia or going into data science and things along that nature.
Great. And for more information on the data standard, you can find us at www.datastandard.io. Thank you so much for joining, and I'll catch you next time.
Thank you so much.